Hello everyone, welcome to Dental Steps at Daily, where we discuss previous year questions from Neet Mds exams. Today we are going to discuss a topic which is hot top favorite, that is the role of saliva in defense and biochemistry. So the question goes like: antibacterial action of saliva is attributed to all except secretory immunoglobulin A, lactoferrin, lysozyme and aminopeptidase. Correct answer is aminopeptidase. Let's see why. Salivary gland defense consists of major salivary gland like parotid, submandibular and sublingual gland secretion, and its role in releasing or secreting antimicrobial enzymes. Also, during inflammation, the polymorphonuclear leukocytes, that is neutrophils, they migrate through the gingival clavicular fluid and they exponentially supplement protein concentrations. So they work as a team. Coming on to the first option, secretory immunoglobulin A action. So immunoglobulin A has a very prominent role in the defense mechanism, as it is anti-adhesion. It's of the microbes inside the oral cavity, and it causes clumping of the microbes, and which aids in the removal of the microbes, and they are digested by the gastric juices and the digestive enzymes. Another thing is the enzyme resistance. So because the structural form of immunoglobulin A is such that it shields from the bacterial proteases, which are the enzymes utilized by the microbes. And another thing is that it neutralizes the toxins as well as the virus particle. So secretory immunoglobulin A action has these type of defenses, and it acts directly against the microbes. Now coming to the next option, which was lactoferrin. Lactoferrin, as the name itself has a ferrin component, which indicates us that this has affinity for iron particle and ferric ions. And by this mechanism, it deprives the microbes such as cheirogynic Streptococcus mutans from ferric ion, and as a result, the ferric ion, the Streptococcus mutans doesn't get nutrition; it doesn't survive. Now, its role in direct lysis of the microbes. For gram-negative bacteria, it is by attaching, but the positively charged N-terminus binds with a negatively charged lipopolysaccharide on the outer cell membrane, and causing the membrane permeability, and as a result the cytoplasmic elements are released, and it causes the cell death of the microbe. While speaking about the gram-positive microorganisms, the lactoferrin targets the lipoteichoic acids, and it weakens the cross-links in the structural wall, and subsequently exposes the cytoplasmic elements, and which are further degraded by the other salivary enzymes such as lysozyme. Now coming to lysozyme. Lysozyme causes the structural lysis of the meshwork of the rigid meshwork of the bacterial wall. So directly, specifically speaking, it affects the beta 1-4 glycosidic bonds in the peptidoglycan layer. These bonds are between the N-acetyl uramic acid and N-acetyl glucosamine. Other role of lysozyme is it has a cationic disruption, that is, the positively charged lysozyme interacts with the negatively charged outer membrane, disrupting the integrity. It also activates the endogenous autolysins within the microbes, which are responsible for the death of the microbes, and it also blocks the virus by binding with the acidic viral proteins. Now, coming on to the aminopeptidase role. What are the roles it plays? So it cleaves the amino acids from the N terminus of salivary peptides, which helps in early digestion, clearing of the dietary protein debris. It is also got a role in pain signal regulation. So it degrades the salivary enkephalins, which are the natural opioid peptide molecule. So it modulates the pain thresholds and mucosal sensory sensitivity. Apart from this, it has a role in inflammation by processing salivary kinins to orchestrate local microvascular permeability, resolving the tissue inflammation. It also neutralizes the pathogen by degrading the foreign peptides which are secreted by the periodontal microbes. By doing so, it safeguards the oral tissues from microbial toxicity. So, if we see if we compare all the options, that is secretory immunoglobulin A, lysozyme, lactoferrin, and aminopeptidase. Aminopeptidase has more of a helping role. It is not primarily antimicrobial. So the enzymatic elevation occurs in periodontal disease, in active periodontitis case, and this can be used as adjunct to the clinical manifestations. Now, comparing all the options, first we discussed secretory immunoglobulin A. So its role is in bacterial agglutination, that is clumping of the bacteria, and it targets the adhesion antigens and peptides, and it has got a direct antimicrobial role. Whereas lactoferrins, it has an iron chelation and causes lysis of the cell wall. It has got metabolic pathways in membranes, and it is directly bactericidal. Whereas lysozyme targets the beta 1-4 of the glycosidic bonds in the peptidoglycan, and it has a direct antimicrobial role. Aminopeptidases, it targets the N-terminal peptide cleavage processing, but it doesn't have a direct antimicrobial activity. If you like the video, please like, share, and subscribe this dental steps and channel. Thank you.